Hello everyone. In this video we are going to use our Excel sheet in order to help us do a two-sample hypothesis testing for means. So let's go ahead and look at our scenario. Here it says that Dallin has two friends who have each decided to start up a new moped company. Trying to be eco-friendly, they each independently invested in hydrogen fuel cells for their power source. Each of their designs are slightly different, and because of this, Dallin suspects that on average, Go Bikes has a different kilometers per liter performance than that of Hydrogen Scoot. He wishes to test at the significance level of 5%. So he randomly selected mopeds from each of their production lines, put a liter of hydrogen in each of them, and drove them until they quit. Here's the data that he collected. Okay, so let's grab our data first. So data, we're going to copy it, and let's go ahead and paste it into our Excel sheet. Go ahead and paste it. Remember here, there's two ways that we can use this sheet. One, if we just had the summary statistics, we could fill out the yellow cells, which kind of sets up your hypotheses, and then the descriptive statistics, or we can put in the raw data like we did here with the row labels at the top, and then you have the groups in column B and the actual values in column C. And then let's go ahead and set this up. So one thing that we have to do is when we do two-sample hypothesis testing, we have to determine who is group 1 and who is group 2. So in here, I try to go down that when we do the hypothesis testing, it says group 1 is Go Bikes and group 2 is Hydrogen Scoot. So I'm just going to go ahead and say equals group 1 equals Go Bikes, and I'm going to click on it because it has to be exactly right. And so I'm just going to click on it so that there's no issues there. And I'm going to hit equals and click on Hydrogen Scoot. It doesn't matter which one you grab, you just need to grab one of them. Okay, the hypothesis here is that we suspect that they are just slightly different, but we don't know how much. The baseline is going to be that they are equal to each other. And typically this is what we're doing with two-sample hypothesis testing. Sometimes you want to test to see if there really is a difference, but most of the time we're testing to see if they are different just from each other, where the baseline assumption is that they are equal. So if we were to rearrange this equation, it could be mu1 equals, and put mu2 on the other side, equals mu2. Okay, now we need our inequality, and our inequality is going to be, for this one, not equals. And the reason is because if we look over here, it says that Dallin suspects that on average, Go Bikes has a different kilometers per liter performance than that of Hydrogen Scoot. So that's why we're going to put in not equals, because not equals corresponds to different. Okay, alpha level is going to be 5% because that's what it says for our significance level. So significance level is just another way of saying alpha, 0.05. Okay, at this point we are ready to do our analyze the raw data and then start asking our questions. So I'm just going to go ahead and click analyze the raw data, and it should go ahead and fill up everything here. All right, so first thing, what type of data are we dealing with? So for this one, we are dealing with numerical data. We know that we're dealing with numerical data. Well, we do have numerical and categorical, but we're really interested in this numerical. We're just using the categorical to compare two groups to one another. So the grouping variable of interest is going to be our moped company, which moped company you are a part of. And the response variable is going to be the kilometers per liter. That's what we're really interested in. So the population of interest is going to be the hydrogen mopeds from Go Bikes and Hydrogen Scoot. So there's actually kind of two populations here, right? We have the populations from Go Bike and the populations from Hydrogen Scoot. The parameter of interest is the true mean kilometers per liter. At how far is like the true means for each group, and then specifically in two samples independent t-testing, what we do is we try to see are these two means different from one another. Okay, and which method should we be using for a test statistic? It says here that we need to be using a two independent t-sample or t-test for a difference in mean with equal variance. Let's see how we can check to do that equal variance. So the equal variance check is we need to look at our standard deviation ratio. So on our table, it's right here, our standard deviation ratio. And how we find this ratio is we take the biggest standard deviation, which happens to be from Hydrogen Scoot, and divide it by the smallest standard deviation. And as long as this thing is under 2, we are good to go. So because we're under 2, we're good to go. Now, there's also another way to do this where we could do the Levene's test, and that's probably like a more thorough way to do it. I'm going to leave that alone for right now. And for our class, we're going to be looking at the standard deviation ratio. Okay, so because of that, we want to be looking at our equal variance, and we can change this graphic from looking at equal variances to also looking at unequal variances, and it's slightly different, but we want to have it be on our equal variances. Okay, the appropriate test statistic here is going to be a t-test. That's what we do when we do our two-sample hypothesis testing for the means. And is our sample sufficiently large? Well, that we need to go look at our summary statistics. We look at the sample size n, and as long as n is greater than or equal to 30 for each group, so we're okay. Or if it says that the population is normally distributed, then we are fine. But for this one, is our sample size is at least 30 for both samples. Okay, so we want to establish this null and alternative. Mu1 minus mu2 equals 0. The alternative, let's see. Mu1 minus mu2 is not equal to 0. Alpha, we said, is 0.05. Okay, calculate data and test statistics. So x bar 1 is going to be the mean for Go Bikes. If we look at that one, 23.5572. x2, which was Hydrogen Scoot, 22.8232. And our test statistic that we're interested in. Now we've got two here. Notice this, we've got two test statistics. Oh, there's also one here that doesn't have a label on it. I need to put this label on real quick. This is the label. Let's just put it in real quick. This is mu1 minus mu2. Just so that we have it labeled. So this is the difference that we saw between these two. And the test statistic is a t-test statistic. Notice how we have two of them. The one that we want is this upper one because this is where we are using for equal variances. This line right here is for equal variances. The bottom one is what we'd use at Welch's T for unequal variance. Okay, so now we can look at our p-value. Our p-value is 0.504. So this is a very common occurrence. And our p-value is going to be greater than our alpha. And we can look at our confidence interval, which is going to be negative 1.46, and it ranges all the way up to 2.355. Now, if we notice in here, the null hypothesis, go back up, our null hypothesis was 0. Our null hypothesis lands inside of this confidence interval. So that's another way that we can say that, hey, we're going to reject the null hypothesis because where we think that the true difference in means actually is, actually the null hypothesis lands in there. So our data really doesn't suggest that we can reject it, so we have to fail to reject it. So because we're doing this, what we are going to do is we say that, hey, Dallin has collected insufficient data, and then here's how we reproduce it for our APA format. T, degrees of freedom, which is given right here, T, degrees of freedom, and we then put in the T statistic that we calculated, that 0.6602 equals the p-value, or the p-value and the alpha, to reject the claim that the true mean kilometers per liter of Go Bikes and Hydrogen Scoot are the same. So we can't reject that claim, and that's how you do two-sample hypothesis testing using our tools here. So that's how you do that. I hope that helps you out. And then we can also look at this graphic real quick, and you can see that if the null hypothesis is true, that's what this blue distribution is showing. And we landed, our observation was not very far away at all. And that's it. That's kind of how this thing goes. Like this this red triangle is at 0.7340. And then here's our confidence interval, kind of where it spans. It captures the original mean, and we're outside of either of these rejection regions. And that's how we do it. So good luck on doing your own two-sample hypothesis testing.